So last thing I want to talk about today is the alcohol abuse. This was covered a little bit in the case study that looked at some of the withdrawal symptoms and some of the behavioral effects that we see with alcohol abuse. As shown in that case study, and I'll talk about this a little bit more in a case study wrap-up video, um, people who chronically abuse alcohol, especially if they're patients, if you're a doctor and you are treating somebody who has alcohol abuse, they are very likely to lie about their alcohol intake, right? Sometimes it can be especially if you have built up tolerance, especially a behavioral tolerance, you can hide when you drink something like vodka that has very little smell, you can hide a chronic alcohol problem. So that's one thing you want to look out for when you see physiological signs of chronic alcohol use. Usually you would do a toxicology screen to see whether or not somebody had alcohol in their system. Okay. So why do people use alcohol? Why is it something that you can become addicted to in the first place? So alcohol is reinforcing a lot of different ways. It acts at multiple points along this pathway, but I just want to sort of outline one way in which alcohol is working. So as I mentioned back in pharmacodynamics, one of the things that alcohol can do is drive the activation of opioid neurons. So this is going to cause the release of endogenous opioids, those endorphins. If you're not aware, we'll talk about this more in the next section. The opioid receptor system is all metabotropic, so it's going to cause, so alcohol is going to drive this opioid neuron, and it's going to release its opioids, and then it's going to inhibit this GABA neuron, right? So it's interacting with the metabotropic opioid receptor on this GABA neuron that's going to inhibit the release of GABA. By inhibiting the release of GABA, that removes inhibition of the dopamine system, and that allows dopamine to release more into the nucleus accumbens. So this is similar to what we talked about with benzodiazepines, right? The mechanism of reinforcement is through disinhibition of the dopamine system. However, in addition to directly inhibiting these GABA neurons, you're also getting inhibition being driven through the opioid neurons, which I believe is much more prevalent in alcohol and barbiturates than it is in benzodiazepines. This is partly because alcohol and benzodiazepines have differential effects on different groups of GABA receptors. As you remember, GABA receptors are pentamers, and depending on which pentamers are present, right? Like if you have an alpha 2 beta 4 or an alpha 2 or alpha beta gamma or alpha beta delta, you end up with different differential effects of a benzodiazepine or alcohol or GABA binding with them. So I think it's a little bit about the way that alcohol interacts with those receptors in a different way than benzodiazepines, but either one, the point is both of them cause a disinhibition of dopamine neurons that are going to increase dopamine release in the nucleus accumbens. And while this is not sufficient for cause addiction, it is what makes alcohol reinforcing. So there are a lot of different factors that can contribute to alcohol abuse. Some are psychological, so stress reduction, which is also referred to as symptomatic drinking or novelty seeking. So novelty seeking, you're going to see a lot more in people who, in adolescents or young kids who are looking for new experiences, and that is so that's going to be, they're seeking a novel experience, and so they try alcohol. And if they have other factors that make them vulnerable, that could be an initial event that sort of starts off a pattern of abuse. If you're using alcohol to manage your emotions, for example, if you do not have any healthy coping mechanisms for stress, you might see an increase in drinking. If you use drinking and alcohol to escape your emotions, you're not building any new coping mechanisms. So when you try and stop using alcohol and you have a stressful event, you have no other way to deal with it other than returning to alcohol. So that drives a lot of the relapses we see. So for example, right now, as you're home, people who are alcoholics for COVID-19 could be really struggling. Right? It's a really stressful situation. A lot of people are making jokes and comments about how you can drink at any time if you're home all the time, and this is a great way to pass the time. But for people who have issues with alcohol abuse, it would be a really trying time. neurobiological factors or biological factors. This is going to have to do with genetic vulnerability and compulsivity. One of these is going to have to do with the expression of the mGluR2 receptor, which is a metabotropic glutamate receptor. It is a what is the word I'm looking for? Presynaptic autoreceptor for glutamate. So it's actually inhibitory. It helps regulate the release of glutamate receptors. It helps regulate the release and synthesis of glutamate, as all autoreceptors do. And people who have different expression levels of them have a greater vulnerability to alcohol abuse. You'll see a figure about that in one of the top hat questions. There are a lot of other genetic vulnerabilities that can come that can contribute to alcohol abuse. I had a friend in graduate school who studied the effects of epigenetics in sperm cells and how that can contribute to alcohol abuse. That's sort of the idea that alcoholism passes down through fathers. And there's some evidence to suggest that that might be true. If you have problems with compulsivity, if you have other risk factors that have led to impulsive behavior, you're also going to be at a greater risk of alcohol abuse. Then there's sociocultural as well, right? So if you are part of a social group that finds alcohol use very acceptable or highly encouraged, you're more likely to experience alcohol abuse. If you are part of a sociocultural group such as Mormons, right, who do not use alcohol. Alcohol is disapproved of within the social group. You're much less likely to use alcohol or try it, and therefore you're much less likely to develop an abuse problem of it. Alcoholism is more common in men. It is most common in middle-aged men. So age and gender are also sociocultural contributing factors. For alcoholism, there are psychological treatment. Most people are familiar with Alcoholics Anonymous. The data behind Alcoholics Anonymous is dubious at best. So there's a great big push to look for pharmacological treatments for alcoholism. So the first one is disulfiram, which is also called anti-abuse. Basically inhibits acetaldehyde dehydrogenase, so it increases the hangover effects. It's basically inducing that genetic change that we saw in 10% of the Asian population where they have two inactive forms of acetaldehyde dehydrogenase, which makes alcohol a very unpleasant experience. It suffers from low compliance. Basically, the idea here, along with naltrexone, is that it's going to make alcohol ingestion really unpleasant. And as a result, both of these are going to have the problem of low compliance. Unless you're forcing people to take this, people can just stop taking it, right? If they just stop taking the disulfiram, they can start drinking again and experience the reinforcing effects. Naltrexone also is going to reduce the reinforcing effects, but it's going to do it through the opioid receptor, the opioid path. So it's going to antagonize the opioid receptors that alcohol would usually be an agonist to. It enhances the sort of sedative and negative effects of the alcohol because, opioid systems are going to sort of reflect that as well. And it's going to decrease the pleasurable effects, right? You're not going to get the same level of disinhibition of those dopamine neurons in the VTA, the nucleus accumbens, so it doesn't feel as reinforcing or pleasurable. A third option is acamprosate. This is a little bit different. It's a partial NMDA antagonist. Its chemical structure is similar to GABA. Its main goal is basically removing withdrawal symptoms. So it makes withdrawal symptoms more tolerable. So you don't have that physiological negative reinforcement to drive alcohol consumption. Alcohol withdrawal is very intense and very aversive. So reducing that aversive experience may help people move through that first section of being off alcohol and make it more manageable. In addition, the longer you've been using alcohol and the longer that you've been abusing alcohol and the more alcohol you drink per day, the more severe your withdrawal is going to be. So if you are a chronic, heavy drinker, withdrawal is going to be very, very unpleasant. So acamprosate might be able to help mitigate those withdrawal symptoms so that you're not driven back by that negative reinforcement. All of these are FDA approved and can all be used to treat alcoholism. So some of the withdrawal effects came up in the benzodiazepine case study, and I think there'll most likely be a follow-up case study question that looks at the questionnaire that is used to assess the severity of withdrawal. But stage 1 is tremors, anxiety, rapid heart rate, hypertension or high blood pressure, heavy sweating, loss of appetite, insomnia. All of these are common when you first stop drinking. Stage 2, 3, and 4 are only going to be seen in people who are chronic heavy users. So it's not going to be seen if you've been binge drinking throughout college and you stop using alcohol. It's very unlikely that you would experience 2, 3, or 4. But if you've been chronically using alcohol heavily for long periods of time, 2, 3, and 4 are much more common. So 4 is what was manifesting. Stage 4 is what was manifesting in our cross-tolerance benzodiazepine case study. Alcohol is one of the rare substances where withdrawal is not only unpleasant, but it is medically serious. With alcohol withdrawal should always be accompanied by medical assistance and support. Oftentimes, benzodiazepines are given to help ease the withdrawal symptoms and help wean the body off and give the GABA system and glutamate system time to readjust and rebalance, because that imbalance between excitation and inhibition, the upregulation of glutamate and the downregulation of GABA are all going to contribute to some of the most physiologically dangerous withdrawal effects. So by giving the body time to readjust to those, you can safely take somebody through withdrawal. So that's all I really want to talk about for alcohol. You could literally do an entire class on alcohol. The chapter on alcohol in the textbook, which is chapter 10, has a lot more information than I've gone through here. But these are just some things that I'd like to highlight because I think they tied in well with the case study and I thought that they were sort of interesting. If there's something else that you want to hear about alcohol, just let me know and I can post another video on it. All right. See y'all later.